Welcome to this virtual class on study session 12, Portfolio Management. And let's go through an exam type question, just to enforce the capital market theory that we have so far discussed in class. An investor purchases a treasury bill with a market value of $10,000 and a return of 2%. The market portfolio with a market value of $20,000 and an expected return of 12%, and there is a US stock included in the portfolio with a market value of $20,000 and a beta of 2.1. So here we have now the question, right? So in accordance to the CAPM, the capital asset pricing model, the expected return of this portfolio is closest to. Well, to calculate the expected return in accordance to the capital asset pricing model, so the expected return equals the risk-free rate. Then we have to add to the risk-free rate the risk premium. The risk premium consists of the market risk premium, so that's the difference between the expected return of the stock market and the risk-free rate. And this market risk premium will be multiplied then with the beta. So here we have, right, the expected return of our portfolio equals the risk-free rate plus the market risk premium multiplied with the beta of our portfolio. Now we know from the question that the risk-free rate is the T-bill rate, or the T-bill, that's our risk-free security. So this risk-free security is issued by the US Treasury at discount and paid back at par at maturity, and the return of the Treasury bill is 2%. So we can include here in the equation 2% plus the market risk premium. The market risk premium, that's the expected return rate of the market portfolio, which is 12%. And we are deducting from it the risk-free rate as the rate of the T-bill of 2%. The market risk premium must be multiplied with the beta of the portfolio, and portfolio beta is calculated as a sum of the weighted betas. So if we take here the beta of our portfolio, then the beta of our portfolio will be the weight of the treasury bill in our portfolio multiplied with its beta. So we know, right, that the market value of the treasury bill is $10,000. In addition to that, we know that the market value of the entire portfolio is $50,000. So consisting of the market value of the treasury bill and the market value of the market portfolio, as well as the market value of the stock of $20,000, that gives a total then of $50,000. So to calculate now the weight of the treasury bill, we take its market value of $10,000 and we divide it by the market value of the portfolio of $50,000. And now please note, because the T-bill, right, is a risk-free security, its risk is 0, so that means that the beta as a market risk measure is 0 then for the T-bill. Then we have to add to it the market value of the market portfolio in our portfolio. So we know the market value of the market portfolio is $20,000. So we take $20,000 divided by the market value of the portfolio of $50,000, and that is multiplied then with the beta of the market portfolio, and the beta of the market portfolio, that's 1. So times 1 plus the market value of the US stock, which is $20,000, divided by the market value of the entire portfolio of $50,000. And we know, right, from the question that the beta of the stock is 2.1, so times 2.1. So that gives then, if you plug the figures in your calculator, you should come up then with a portfolio beta of 1. So it's then 1.24. So that's a portfolio beta of 1.24. The 1.24 portfolio beta is included above in the equation to calculate the expected return of the portfolio. So include here 1.24. in the equation, and that gives then an expected portfolio return of 14.4%. So that means that the correct answer is answer B. Okay, so that's this calculation, right, of the expected return in accordance to the CAPM. Do you have any questions regarding this example? Okay, Sean?
How do you calculate the beta for the stock?
Okay, so the question is how to calculate the beta for the stock. So how to calculate the beta for the stock. So let's have a look at it, right? So the beta of the stock is calculated as follows. You have to run a regression between the stock returns and the market returns. So I take here on the vertical axis the stock returns, and on the x-axis the market returns. So, for example, we can take here the stock of UBS that we are regressing against the market proxy, and the market proxy that we can take is the SMI, for example, the Swiss market index. Now, next we can take daily returns of the UBS stock and the SMI, the Swiss market index. So let's assume, right, that the SMI went up yesterday. The return of the SMI was 1% yesterday. And let's assume, right, that the stock return of UBS was 2%. So that gives the first return point in this diagram. Then we can take daily UBS stock returns and daily SMI returns, right, for 2 days ago, 3 days ago, and so forth over 1 year. And that gives then a cloud of return points in this diagram. Then next we can construct a regression line that will best fit then this cloud of return points. This regression line that will best fit this cloud of return points can be constructed using the least square method. So here we have then the regression line, and the slope of this regression line, that is then the beta of the stock. So if we take here the slope of the regression line, then we know, right, that the vertical axis, that's our dependent variable y, and the x-axis, that's our independent variable x. So the slope of the regression line is given by the change in y, so the change in the dependent variable, divided by the change then in x here, and the change in x, that's then the change in the independent variable. So if we take now the slope, right, of this regression line, then the slope equals the change in y divided by the change in x. So the change in y, that's the change in stock returns. So change in stock returns, so the stock return of UBS, and that you're dividing then by the change in market returns. So here we have then the change in market returns. So here in market returns. And that gives then the beta of our stock. So the beta is therefore a sensitivity measure which tells us how much the stock return will change due to a change in market return. So for example, if the beta of the UBS stock is 1.2 and the market return goes up, let's say by 2%, then we can expect, right, that the stock return of UBS will increase by 2.4%. Sean, did I answer your question about the beta? Okay.